This video we're going to look at coalescing or coalescing objects. So this is when two objects join together. So this could have been done earlier on in our principle of conservation of momentum video. It is exactly the same idea as before. So in this example it says a body of mass 2 kilograms moving on a smooth horizontal surface at 3 meters per second collides with a second body of mass 1 kilogram which is at rest. After the collision the bodies coalesce, so that means they join together, so they move as one body. Find the common speed of the bodies after impact. So this is your diagram. So before you've got the moving as one body. I could have changed my second diagram just so you can see. You could have drawn your second diagram just as this. So you've got the two circles, the 2 kilogram one and the 1 kilogram one. That would have been exactly the same. That would be my preferred way of doing it, to be honest. I'll do the next one like that if it comes up. So what we're going to just do, momentum before, again, same idea. Momentum before equals momentum after. Okay, so the first one, you've got 3 for this one here. It's 3 times 2. For this one, it's just 0. And for this one, it's going to be the total mass then, which is 3 kilograms. So it's just 3V. So if we do that, very easy, we sum, that's just 6 is equal to 3V, a wee bit of working out, V works out to be 2 meters per second, that is it. Okay, the next question is a vectors question. It says a body of mass 2 kilograms, moving with velocity 8I minus j, collides with the body of mass 3 kilograms, moving with velocity of minus 2I plus 4j. On collision, the two bodies coalesce, so they join together, find the common velocity of the bodies in vector form and hence obtain the common speed. So a wee bit of extra working out to do. Let's do a wee diagram here. So we've got before, so you've got your 2 kilograms. Don't worry that they've got vectors going on here. I would just say that this one's moving with velocity and it was 8 minus 1, written as a column vector, meters per second. It hits this body, which has a mass of 3 kilograms. And it's moving with a velocity of minus 2, 4. Okay, clearly my arrows aren't going in the right direction, doesn't matter. And then after, you've got the two bodies in, so 2 kilograms and a 3 kilograms, but together they're moving with some velocity V, and I've done it in vector form, and that's what we're trying to find. Okay, so momentum before equals the momentum after. That's all we're doing here. So for the first one, it's going to be 2 upon 8 minus 1 plus 3 upon minus 2, 4 is equal to, and their common mass, remember common mass here is going to be 2 plus 3. So this is where this is magically coming from. That's going to be 5 times my vector V. And we'll just go with this and see what happens. So let's just tidy it up. It should be a bit of working out. 16 minus 2 plus minus 6, 12 is equal to 5V. So tidy it up again. What's that going to be? 10. Oh, 10, lovely, is equal to 5V. So my V works out to be, divided across by that 5. That's why it's so nice. It's 2. So let's just write that back in their form. 2I plus 2J in IJ form. Meters per second, that's a velocity. Your speed then, let's just draw a wee diagram. 2I means 2 to the right, 2J means 2 up, and that's going to be your speed. So your speed then is the magnitude or the modulus of this, whatever way you want to say it, and it is just done by finding the length of that by Pythagoras, and if you did that on your calculator you're going to get root 8, which is an exact perfect answer. Also 2 root 2 it will come out as probably, and the 2 decimal places 2.83 meters per second. The 2 decimal places or the 3 sig figs. So pretty much just the same, just as easy if it's in vector form. Lovely wee question.